You walk into the produce section on a Saturday in July. The watermelon bin sits dead center, two stacks side by side. One has a yellow tag, seeded. The other, green, seedless. The seedless bin is 3 times deeper and the price is double. You reach for the seedless. No spitting, no stopping, no 5-year-old lobbing black pellets across the backyard. You have paid that premium 100 times without asking the question that should have hit you the first time you bit in. How do you grow a fruit without seeds, when seeds are how fruit grows? You assume it is a different breed, maybe genetically modified, or perhaps it evolved naturally over time, like seedless grapes. You trust the science happened somewhere far from you. But here is something that might surprise you. That seedless watermelon was built in a laboratory in 1939 by a Japanese botanist who weaponized a poison extracted from autumn crocus flowers. The chemical rewrote the plant's chromosomes. Every seedless watermelon sold today is a genetic dead end that cannot reproduce on its own. The seed to grow it costs up to $300 a pound. And the reason you never see a black seed is the same reason the plant needs a second fertile watermelon planted next to it just to set fruit. That watermelon is sterile. In 1939, Hitoshi Kihara at Kyoto Imperial University created a watermelon plant with 3 complete sets of chromosomes instead of 2. He called it a triploid. Every normal watermelon has 2 chromosome sets, 22 total. Kihara's plant had 33. The extra set came from chemical intervention and locked the fruit into a biological paradox. It could grow, flower, and swell into a 20-pound melon, but it could not make viable seed. For 12 years, the discovery sat in an academic journal gathering dust. Then, in 1951, researchers at the University of Chicago published the roadmap that made seedless watermelons commercial. Cross a tetraploid parent with 4 chromosome sets with a normal diploid, and the offspring would be triploid. Sterile, seedless, and farmable if you planted a pollinator nearby. Nobody wanted them. Seeds were not a problem. But by the late 1960s, field trials proved seedless varieties could yield just as much fruit per acre as seeded ones, and consumers would pay double. By the mid-1980s, seedless watermelons accounted for 10% of U.S. production. By 2014, 85%. Today, the seeded bin sits half empty in the corner. The seedless watermelon won because nobody wanted to spit. Here is how it is actually made. The process starts in a greenhouse with a chemical that treats gout and was once used to poison enemies. Colchicine is extracted from autumn crocus seeds. It binds to tubulin proteins in dividing cells and prevents chromosomes from separating during mitosis. The cell duplicates its chromosomes but never divides. The result is a cell with twice the genetic material. Seed companies take a normal diploid watermelon seedling and treat it with dilute colchicine, 0.05 to 0.2% applied to the growing tip for 6 to 12 hours. The chemical kills most tissue. What survives has doubled chromosomes, 4 sets instead of 2. Tetraploid. You can see it in the leaves. Tetraploid leaves are thicker, darker green with shorter petioles. The pollen grains are visibly larger. The flowers bloom later. These plants grow slower, yield less fruit, and serve one purpose. They are parents. The tetraploid plant is grown in a controlled greenhouse. Its flowers are hand-pollinated with pollen from a normal diploid. The diploid contributes 11 chromosomes. The tetraploid contributes 22. The fertilized seed has 33 chromosomes. Triploid. That seed is the product. The entire seedless watermelon industry runs on those triploid seeds. A pound of triploid seed, about 4,000 seeds, can run $300 to $600, compared to $20 to $50 for the same weight of diploid seed. And triploid seed is finicky. It has thicker, harder seed coats. Germination rates run 70 to 85% compared to 95% for diploid varieties. The seed must be started in warm soil, 85 to 95 degrees Fahrenheit. Below 75, germination collapses. Most growers start triploid seed in climate-controlled greenhouses 3 to 4 weeks before transplanting because direct seeding into cool soil wastes hundreds of dollars. Once seedlings move to the field, the real complication begins. The triploid plant is sterile. Its flowers produce no viable pollen. Without pollination, the flowers abort. No fruit forms. So growers plant a diploid variety, called a pollinizer, in the same field. 1 row of diploid for every 2 to 3 rows of triploid. The diploid flowers bloom at the same time. Bees transfer the pollen. That pollen does not fertilize the triploid seeds because there are no seeds to fertilize. but it triggers the fruit to set anyway. The plant releases growth hormones and the ovary swells into a full-size watermelon. The diploid pollinizer produces its own seeded fruit, which must be sorted out at harvest. Some growers choose pollinizers with different rind patterns to make sorting easier. Inside the fruit, the triploid watermelon still produces seed structures. Those small, soft white flecks you bite through are seed traces. They form because pollination triggered fruit set, and the ovules started developing. But the mismatched chromosome count aborted the process before a mature embryo could form. You are eating the shell of a seed that never finished. Triploid yields match or fall slightly below diploid yields per acre, between 30,000 and 40,000 pounds for both. The advantage is not in the field. It is at the register. Here is where the story flips. You might see a product that is more expensive, harder to grow, dependent on a second plant just to fruit, offering no yield advantage. A gimmick. A way for seed companies to charge farmers 5 times more for something that used to be free. But walk down the produce aisle and count the bins again. Seedless watermelons dominate because consumers chose them. Not once, but every week, in every store, for 40 years. In 2014, 85% of U.S. watermelon acreage was seedless. By 2020, some distributors reported 95% seedless in certain regions. The seeded watermelon, the one that reproduces on its own, the one that has fed humans for 5,000 years, is now the niche product. That shift did not happen because seedless watermelons taste better. Blind taste tests show no significant preference. It happened because convenience won. Spitting seeds is a minor inconvenience, maybe 5 seconds per slice, but across a summer, across a family, across a generation of kids who never learned to aim, that inconvenience added up. The triploid watermelon is a product of controlled sterility. It cannot make seed, cannot reproduce, cannot survive without human intervention at every step. It exists because a botanist in 1939 asked what would happen if you broke the rules of cell division. And 30 years later, farmers and consumers decided a fruit that cannot reproduce itself was worth twice the price of one that could. That $300 per pound seed is not a scam. It is the cost of rewriting biology. Every triploid seed represents a tetraploid parent created with poison, grown in a greenhouse, hand-pollinated under controlled conditions, and harvested for a product that will never produce seed of its own. The seedless watermelon has grown into a multi-billion-dollar global industry, with demand still projected to rise another 20 to 30% by the end of the decade. That growth is driven by preference. The science is not new. Kihara published the concept in 1939. Igzi proved it scalable in 1951. What changed was the willingness to pay for a summer afternoon without the spit cup. Now try this. Next time you're at the store, pick up a seedless watermelon and look for the variety name. You will see fascination, captivation, troubadour, or exclamation. Those are triploid varieties, bred and patented. Then walk to the seeded bin, if your store stocks one, and compare the price per pound. The difference is rarely less than 50%. That price gap reflects the cost of triploid seed, greenhouse starts, planting a pollinizer variety, and managing a crop that will not fruit unless bees do their job at the right time. The seedless watermelon is more expensive because it is harder to make, and people pay it because the alternative is spitting seeds into a bowl for 8 weeks every summer. The next time you bite into a slice and taste nothing but sweet red flesh and soft white flecks, remember this. That fruit exists because a cell was forced to duplicate its chromosomes and forbidden from dividing. It is a biological dead end, kept alive by hand pollination, heated greenhouses, and diploid neighbors planted in alternating rows. It cannot make seed, it cannot reproduce. It would vanish in a single generation if humans stopped intervening, and every summer, millions of people paid double to eat it. That is the process. We reveal how things actually work, one story at a time. If there is something you would like us to explore next, let us know. Until then, trust the process.